Hello, everyone, and welcome to today's webinar, sponsored by the HIBAR Research Alliance, also known as the HRA. I'm Scott Slovic from the University of Idaho, and I'll be the moderator for today's one-hour event featuring Gaurav Sant and Thomas Traynor from UCLA's Institute for Carbon Management. This is the 14th in our series of webinars for researchers, research administrators, and others who are interested in what we call highly integrative, basic, and responsive research. Our previous webinars are now available for viewing on the HRA website, which can be found at hibar-research.org. A recording of today's webinar will also be posted on the HRA website. Before today's presentation, I'd like to offer a brief heads up about our next webinar in this series, which will take place on December 7th, featuring presenters from the University of South Florida, who will share their experience in designing and implementing USF's Pandemic Research Response Network. They will describe how USF is applying lessons learned from the pandemic network that can help to coordinate institutional networks in response to other major societal challenges. Further details about December's webinar will be available next week. Now I'd like to explain the structure of today's meeting. We'll begin with a brief overview of the HIBAR research concept by Lauren Whitehead. Roger Wakimoto will then introduce Gaurav and Tom, who will speak for 20 to 25 minutes about creating sustainable solutions for permanent carbon removal at scale, a major HIBAR-related project. And we'll then have approximately 20 minutes for Q&A, followed by an opportunity for Gaurav and Tom to offer a few final takeaway messages. And now we can get started. Dr. Lauren Whitehead, the director of the HRA, is a professor in the Department of Physics and Astronomy at the University of British Columbia. He'll briefly introduce the concept of HIBAR research and the HRA organization. Lauren, over to you.
Thanks very much, Scott, and I will indeed be very brief. So the HIBAR research is found in projects that embrace two key dualities. Each HIBAR research project integrates academic leadership and societal leadership, and it also integrates academic purpose and societal purpose. Well, these are just words, but they're useful words. And in fact, they help to describe the use of the acronym HIBAR research. So our key idea, and which you'll hear today, is that all four of these ideas are integrated in any given HIBAR research project. And so that's why we use the words highly integrative to describe HIBAR research. And also, importantly, they include the ideas on the left of being university-oriented or basic, and on the right in the diagram, being responsive to societal need. So projects that have all four of those characteristics are described as highly integrative, basic, and responsive, or HIBAR for short. It's a useful term and a useful idea for a couple of reasons that I'll mention and then move ahead. The reason is that these ideas that are at this intersection point of HIBAR research are narrowly defined. These projects are not actually that common. They are present at universities all over the place, but not super common. And that's actually a really exciting idea because those projects are also very impactful, as you'll hear today with a wonderful example. And so if we've got a relatively small number of highly impactful projects, it's a sensible idea to consider doing more. And that's what the HIBAR Research Alliance is about. It's a distributed network of experienced volunteers who are well organized and united in their support of HIBAR research. So the aim of that organization is to increase the prevalence of university HIBAR research from about one project in 20 today to about 1 in 5 by 2030, while improving all types of research. So there will be no losers if HIBAR research projects become more common, but society and the academic world together will clearly gain from that. So this will help universities to respond more effectively to societal need while increasing the excellence of their basic research. We have a wonderful example here today. So the work of the UCLA Institute for Carbon Management, ICM, offers insights for carrying out HIBAR research at scale. This is an example of a university project with deep societal connections, yielding major new academic insights and societal benefits. ICM is creating and developing sustainable solutions for carbon removal, demonstrating that they are effective at a scale that is globally relevant in a range of carbon-intensive industries, including power generation and cement and concrete manufacturing. These efforts beautifully demonstrate those valuable HIBAR traits I've mentioned of being discovery-oriented while focusing on public impact and harmonizing the insights of academic and societal experts. So on that note, Scott, I will hand back to you.
Thanks very much, Lauren. And now I'm pleased to introduce Dr. Roger Wakimoto, the Vice Chancellor for Research and Creative Activities at UCLA, who will say a few words of introduction for today's featured presenters. Roger?
Thank you very much, Scott, and thank you for all the attendees. The actual title, which you can get from what Lauren was talking about, is Creating Sustainable Solutions for Permanent Carbon Removal at Scale. And I'm very pleased to introduce two UCLA researchers to you. The first is Gaurav Sant. Now, he is the Pritzker Professor of Sustainability and the Henry Samueli Fellow at the UCLA Henry Samueli School of Engineering and Applied Science. He holds faculty appointments in the departments of Civil and Environmental Engineering, Material Science and Engineering, and is a member of the California Nanosystems Institute. We often refer to that as CNSI. And Gaurav is also director of the Institute for Carbon Management, and Lauren alluded to this earlier. Second speaker is Thomas Traynor. He is the translation leader at the Institute for Carbon Management. In this role, Tom is responsible for the translation of new technology from the research phase to the commercial scale implementation. And for the last 14 years, Tom has worked on process development and scale up at Honeywell, UOP, where he has 13 publications, including 7 patents in the fields of renewable energy and chemicals, absorbent applications, and heavy oil processing. So we really hope you enjoy this webinar today on a problem that, of course, is of world importance, and that's attacking climate change. So turn it over to our speakers.
Thanks very much, Roger. So thanks everyone for being here. I'm going to start off by telling you a little bit about the Institute for Carbon Management. My name is Gaurav Sant. Before going too far ahead, I sort of have to start with acknowledging Roger, actually, and the former Dean of Engineering at UCLA, Jayati Murthy, because if it weren't for the two of them, I don't think the Institute in the form that it is or the form it were would actually have ever been set up. So like Roger said, I lead the Institute for Carbon Management, and what we are is we're a translation institute. But really what ICM does is we pioneer technology translation to create transformative carbon management solutions. We prioritize 4 key areas. There's a key focus on decarbonizing industry, and that's really related to the development of breakthrough technology for carbon mitigation, removal, and for creating a carbon-free energy economy at scale. We're very focused on engaging legislators to be able to create policies that support carbon management. We think this is, again, fundamentally important. We're super focused on enabling transparency and truth about carbon management by providing centralized resources to be able to explain and understand complex data in an easy to understand format. And finally, I think the other part, which is really important, and I think it's really important to also our role as a public university, is to create awareness to empower the public to adopt new solutions to the carbon management challenge. I think a big part of sort of what the Institute really does, and when we speak about translation, is now really turned into a process. And this process, which I would say has been years, decades in the making, starts out with a landscape analysis. And this landscape analysis really involves doing a really broad and deep overview of a technology landscape, whatever technology area that might be appropriate. At the end of the landscape analysis, which goes between 6 to 24 months, starting to really work on bench scale concepts and understanding the level of maturity that they're at. Once we spend time understanding, developing, building out the bench scale concepts, we go into translation mode, which involves the design, the optimization, and the fabrication of larger systems. And this really involves prototypes, which are either devices, which are processes or integrated systems, and which leads into the ability to create startup companies. So we think startup companies are a really important endpoint of the work that we do, because we want there to be impact to society. And we think that this idea of being able to take technology from the bench scale to commercial systems is really the most direct way to do it. We have a track record of doing this, doing things that are scalable, that are cost effective and cost accessible, and that are impactful. And because everyone likes to win a prize, the story I often like to tell is ICM's work has won some really nice prizes. So we're the first university, UCLA is the first university to ever win an X Prize. We won the NRG COSIA Carbon X Prize in 2021. And we followed that up with a very nice win of the Livability Challenge, which was run by Temasek in Singapore, which also happened in 2021. Both of these are both of these prizes for work that we do in marquee areas related to cement and concrete decarbonization for the X Prize and atmospheric carbon removal for the Livability Challenge. So really, the focus of ICM is based on creating real technology and demonstrating its scalability and how it makes a difference to both carbon management in general, but also creating material sources and material supplies that are critical to the clean energy transition. So one of the things that we recognize very, very early on is that focus is important. And so ICM only works in two areas, right? So we work in one area which is related to the creation of technologies for carbon dioxide removal, utilization, and avoidance. And another area which is related to the creation of technologies for creating new supply chains and processing approaches for critical materials that are infinitely important to the energy transition, and with a focus on lithium, nickel, cobalt, manganese, and molybdenum. Now, with all of the work that we do, one of the things that we've really focused on is this idea around demonstrating success at a minimum viable scale. And so, we've chosen that a process that achieves a throughput of 1,000 kilos per day of CO2 equivalent, or for example, of producing something like lithium, is really the right scale to be operating at and the right scale to be demonstrating systems at, because this is large enough where you can really get a good understanding of how success might actually evolve and what might be needed to make success evolve at a commercial scale. So one of the things that you can tell, we've been really focused on sort of three action themes. There's a mission-driven focus on impact and outcomes. I think this is really important, and the way that we approach this is we really think of ICM as a vehicle, as a mechanism to take classic discovery research that we do at universities and put it into a translation funnel where when it comes out on the other side, you've taken some incredible ideas, some incredible talent, and you really mobilize a mechanism to use it effectively. It's all based on teams of people that are agile and are able to pivot quickly. And there's a really strong focus on drawing on existing state-of-the-art knowledge systems and processes. And this is one of the reasons why we've got incredible talent like Tom that will speak to you in a short while, where we want to try and bring back people from industry into academia rather than the other direction, which is what happens most often, because there's an incredible amount of expertise in the industrial sector that we can use to really catalyze the development and translation of new technology. One of the things, which is important to think of is when you build an organization, structurally, what does it look like? And the way that ICM is organized is it's organized as what we would call as a focused translation organization. And this really sort of leads into the HIBAR Research Alliance mission as well, where FTOs and ICM, which is an FTO, is a special purpose organization. It was created to solve technological challenges that are not addressed by existing structures of academia, industry, or government. So if you look at the types of work that's typically done by these three different stakeholders, what ICM does is actually distinguish from each one of these. As an important sort of explanation, ICM develops and de-risks technology to a scale that nobody else does. We work in an area that requires a coordinated level of engineering and system building that's not accessible in academia classically. And the work is really designed to benefit society in a way that industry usually would not take on because A, it's either far too high a risk or something you cannot rapidly monetize. And finally, because we think decision-making and speed of decision-making are of the essence, the idea is to create an organization which is basically led by a CEO with a culture that's similar to a startup. With the objective being that you use this combination of talent and structural organization to take on moonshot projects, which stay true to systematic road mapping and systematic best practices of technology development, but could let you really do things that would be really hard to do in any other way. Now, the way that ICM is organized, we've been around for about, give or take, about 4 years now. We've got about 6 companies that surround the institute. These are all companies that were born from technologies that were created at ICM, and they span a wide range of domains, right? So essentially going from cement and concrete decarbonization to carbon removal from the atmosphere, to carbon capture from the atmosphere, to being able to create new processes for the extraction and separation of lithium, which, as we know, is needed for things like batteries. These companies, as you can imagine, are at different sort of stages of maturity. Some of them are getting ready to commercialize and operationalize commercial plants. Some of them are still in technology development and will continue to be in technology development mode for the next couple of years. We are truly cross-disciplinary. So ICM was organized and continues to be organized under a campus-wide technology translation impact partnership. And I think this is why I remain so thankful to Roger, because one of the things that we were able to do is we were able to go out to all of the key stakeholders around the campus, the deans of the different schools, the School of Engineering, the School of Management, the School of Public Affairs, and also the College of Letters and Sciences. And all of them came together to support ICM in the format that it is. And obviously, having the Vice Chancellor of Research support the effort is extremely important, because one of the things that we did want is we wanted this to be a campus-wide initiative. We did not want this to be born in engineering or in the sciences, because we thought having integrative buy-in is extremely important to having success emerge in an area of broad societal relevance. So who do we work with? Why do we work with these entities? We work with basically everyone that you can think of. We work with federal and state agencies. We work with corporations and foundations. We work with Fortune 500 companies. We work with venture capitalists, because we think that all of these stakeholders are all fundamentally important to being able to deliver impact at different levels and at different scales. And so, you need to have a very inclusive model, but also a model that lets you engage with entities that you typically would not as a university. With that said, getting to the end, one of the things that we've been incredibly fortunate about is having a world-class advisory board. The board is extremely important for a couple of reasons, right? Offers sage advice, offers really grounded advice, but also helps you open doors. It's also a group of people with incredible experience doing a bunch of very different things. And I think one of the things that is needed is we need this kaleidoscope of opinions to actually come together. The work that we do is in many ways very non-traditional to a university, and having people that have experience beyond the university, I think, was extremely important in the construction of the board and in having access to the advice that the board offers. With that said, happy to conclude and pass it over to Tom, but really, like I said, the mission of ICM as I see it is to decarbonize tomorrow starting today. And with that said, I'm happy to hold on and take questions when the time is right. Over to you, Tom.
Let me just share my screen here. There we go. Okay, so I'm going to present an example at ICM of HIBAR Research, our Sea Change project. So really, when you think about carbon management, there are a lot of current technologies that are being developed, and Sea Change really seeks to differentiate itself from those technologies and solve some of the problems that they all tend to have. One example of current technology being developed is carbon capture and sequestration. I think many people are aware that that involves taking CO2 out of either a point source or the air and then storing it underground. This is an energy intensive process, and it has the risk of CO2 leakage from these storage areas. Direct air capture has similar problems. You're talking about very low concentrations of CO2 in the atmosphere, which means you have to move an enormous volume of air, and you end up with very large scale contactors, which then produce a product, CO2, that needs to be compressed for transport, or you need an extensive infrastructure. Other technologies like waste carbon utilization often require pure CO2 as an input, and the economics really aren't there yet for most of the processes because they're so energy intensive and have relatively low conversions and yields. Sea Cycle seeks to go beyond the geological sequestration. We offer a clean, low-cost solution that has minimal inputs, seawater and energy. It produces a durable stored CO2 product as mineral carbonates, which, a lot of people are very familiar with these in seashells. And it's a cost-effective solution. So the solids can be used as building materials or disposed of safely in the ocean with a valuable co-product of hydrogen that can be used as a clean fuel. So, Sea Change, how does it work? We take seawater and we pass it through an electrolyzer. Electrolyzers, on the cathode side, you're generating hydrogen and base. That base is used to precipitate the dissolved calcium and magnesium as hydroxides, which then can be re-equilibrated and carbonated either in the plant and separated it as solids, or you can do the carbonation in the ocean where it's a little bit more economical. The other side of the electrolyzer, the anode produces acid, oxygen, and some chlorine. So we have a processing train to first remove the chlorine, reduce it back to ionic species, and then neutralize the analyte so that it's back to a neutral pH and can be returned to the sea. And so when we talk about how is this a HIBAR process, I mean, the translation life cycle involves multiple interdisciplinary activities that are all led from the university. We have electrode selection and fabrication. So I mentioned the possibility of evolving chlorine. If we select the right materials and develop them, we can mitigate the chlorine evolution from the start by selecting an anode material that involves minimum chlorine. This is fundamental research that can be done in the university and has an immediate applicable scale to this process and other seawater electrolysis type processes. We also talk about separating the effluent and the possible uses for it. That's something that it's relatively common technology in the day, and bringing in technology partners from industry can help us understand the best ways to do solid separation in aqueous environments. We're doing rapid prototyping of our electrolyzers and integrating them into the balanced plant. We're also demonstrating this technology in both the Port of Los Angeles and in Singapore. And we're completing life cycle analysis. These are all important technologies that are really what's required to develop the technology from the bench scale proof of concept to something that, like Gaurav mentioned, is de-risked and that then can be a standalone company. I'm going to talk a little bit more about a couple of those sections of translation, particularly when we talk about cath-like product separation and quantification. I mentioned that that's an important part of our process. It's also a concept that in the carbon capture industry, we hear MRV, which is measurement, reporting, and verification. It's how we prove that the carbon capture we're doing is actually carbon capture and that it has permanence. So our process addresses a lot of the key areas that could be seen as risks for sequestration technology, primarily in understanding that our process does allow the flexibility for complete solid separation. So instead of having to have some uncertainty of the carbonation process in the ocean, for example, we can separate solids and carbonate them on land and physically weigh our seashells. We can also re-equilibrate on the plant and discharge a fully carbonated aqueous stream as well, which is an advantage to some of the other ocean alkalinity-based CDR projects. The benefit of scaling in the university like we are is we're able to validate some of those different measurement technologies and techniques on the pilot scale before they're implemented on the large, the commercial scale. So the pilot plants are designed with sensors in place, not only just to measure weights of solids and separate them, but do the inline analysis of things like calcium and magnesium, which may sound trivial, but it's relatively difficult to do ion selective measurement in a complicated environment like seawater. So the plant allows us to validate some of those technologies and measurement techniques so that we can guarantee our carbon capture and sequestration is as advertised at the quantities and capacities we've discussed. Mentioned, we also have a plant that's being built in Los Angeles. It's at the site pictured here. Right now, we're actively in the process of building the plant. You can see the barge here delivered, which will be adjacent to our plant site where we have our water intake. Let's see. We also talked a little bit about rapid prototyping on the electrolyzer. Electrolysis is widely used technology to generate hydrogen already. We're taking a system that sounds like it might be common and applying it to seawater, where you have divalent cations that can foul. We've been able to demonstrate that at the lab scale, and then where we have a single cell with an anode and cathode. And then at our pilot scale, we're going to be able to stack multiple cells and demonstrate how that works. And you're able to actually scale in multiple directions and allow for a relatively small footprint for this type of process.
Thanks very much, Gaurav and Tom, for those very fine overviews and the introduction to such an interesting example of your work at the ICM. So I have some questions that I've prepared to seed the conversation. The field that you're describing in this particular example is very different from my own field. So it's hard for me to recognize where the contributions of new discoveries are specifically. And one important aspect of HIBAR is the exploration of basic knowledge, the contributions of basic new knowledge. I wonder if you could talk a little bit, maybe using the Sea Change project as an example, about where ICM is contributing some new basic knowledge to the field of electrolysis. I suppose you would describe the larger field. And then related to that, it would be interesting to know something about how this knowledge is being shared, because it's related to questions of patenting such new discoveries versus publishing on those issues. And I'm wondering whether you find any challenges or tensions with regard to the effort to patent these discoveries, the new knowledge that you're creating, versus contributing to the academic field by way of publication. Wonder if you have any thoughts about this.
Sure, Scott. So I'm happy to try and speak a little bit. Central tenet of something that we keep in mind is we are a public research university, and what that means is anything that we do, we want it to become publicly available and publicly accessible. That being the case, a good example of the work that we're doing that relates to basic science, basic discovery is work around developing new types of electrodes that we think are going to be highly efficient, highly scalable, highly appropriate to, for example, the sea change process. The approach is all conditioned around sort of really basic understanding around materials chemistry and how you use understanding of basic materials chemistry to do things that are useful in an engineering manner, so to speak. That being the case, for all of the work that we do, where there's new knowledge that emerges that we think is commercially valuable or commercially exploitable, we will patent everything that we do. And once you're into the patenting phase, of course, you can go out and disclose. And so while it might be thought that there is a tension between, doing things that are commercially valuable and non-disclosure of information of that sort, we don't actually see it that way. I think it's all about following the right sequence, right? Protect your information and then go out and share it. Because you never know what unexpected discoveries are going to come from other people's work that continue to work on the things that you do, which I think is a big part of also the research process.
One of our attendees is asking, or is acknowledging, that these methods are clearly proactive, but wondering a little bit about the issue of scale and whether they can be scaled to avert climate catastrophe. Maybe thinking of the Sea Change project in particular, but perhaps also the larger portfolio of research that you're doing at ICM. So this is exciting, but where are we at in scale? We have electric cars on the way, but too little too late, or not?
So I can try and offer some context on this, and then Tom should add in as well. So the way ICM's mission mandate is set up, we seek to make a difference in a decade. That being the case, we have to be on a pathway where we think we can actually do that. I think the work that we're doing, in fact, if it does succeed, does have the ability to make a difference. But there are two aspects to this, right? So one is actually the build out of the technology and demonstrating that it works. And then there's really the adoption, the exploitation and scaling of it, diffusion of it into society at large. I think while we are well on track to do the first part, the second part is obviously going to take time, but we've got to keep in mind that the climate change is such a big deal that, in effect, it's an issue that requires the reindustrialization of the world in the next 30 years as we've never imagined. These are, expectedly and realistically slow processes that take a long time and take a lot of money. That being the case, should we remain optimistic? Absolutely. Technology has helped us solve nearly every single problem that has been thrown at us so far. And to imagine that that isn't going to happen again is probably not a realistic outcome. And the anecdotal success example I like to offer is, think of the COVID pandemic. Had a pandemic come along, we said, you know what, we need vaccines from a standing start, give or take, in about a year there were vaccines. Moral of the story, as long as we're committed to it, we're willing to put the resources behind it, and we have the will to do it, solutions always emerge. But perhaps I am the eternal optimist. So over to you, Tom.
No, and I can speak a little more discreetly to sea change as well. Like Gaurav said, when we look at projects that have the chance to be impactful within a 10-year period. And we can put some numbers on that. So the problems we have with CO2, I think the industry agrees that to be impactful, we're talking about gigaton per year scale removal, and probably on the order of 10 gigatons a year to actually make a difference over the long term. So when we look at technology, we think, what is actually going to be able to do that? And I sort of mentioned that in my first slide. When you talk about like direct air capture, you're talking about huge air contactors and a massive network of pipes and storage caverns for CO2. Sea change, we're not limited by existing storage capacity. You can use the ocean literally as your carbon sink with this type of technology, and it doesn't take a large fraction of the mineral concentration in the ocean to do that. We're talking on the order of 1% of all the mineral, calcium and magnesium dissolved in the water to get us back to pre-industrial levels. I mean, no one's suggesting that this is the only potential solution, but it has to pass the eye test to even really get started. Electrolyzers also are being widely deployed for the hydrogen economy and are known to scale pretty well. So we are taking advantage of the existing infrastructure and electrolyzer technology and applying it to a new application that we do believe is scalable to an impactful number.
In addition to the issue of scale, there's the question about speed, and you've both been emphasizing this 10-year horizon that you're really aiming for in accomplishing some of these projects. I wonder if we could talk a little bit about the relatively rapid pace of your approach, given the urgency of some of the issues that you're working on, and how this pace, this relatively rapid pace, influences your approach to developing cross-sectoral partnerships, and in particular, whether the process of identifying and engaging with people who have cross-sectoral expertise is a particular challenge because of the time window that you're working in for these projects.
It is a compressed schedule to be impactful, right? Honestly, I really haven't seen that as a hurdle. We're operating at similar paces to companies that are deploying and developing technology. It's a little different because we don't necessarily have the infrastructure of a big company, but you think about the ways that you can sort of short circuit the timeline. Developing industry partnerships early on, that's a critical aspect. I think when you talk about a big engineering project, almost every one of the carbon capture processes is going to need some sort of EPC involved with the project. So developing partnerships outside the university is definitely important to be able to short circuit that time scale.
In addition to working cross-sectorally with partners outside of the university, there's the issue of how to involve doctoral students in your work. And Gaurav mentioned that HIBAR teams have to be agile and sometimes pivot quickly, but this may not be compatible with the process of involving PhD students who can't always change their dissertation topics quickly when a new opportunity arises or a new need. So Do you involve PhD students in your work? And if so, how do you manage this potential problem that they can't pivot quickly in response to the needs of a project?
Yeah, so great question, Scott. So it's all about sort of deploying talent where talent is best deployed, right? And so what PhD students should be working on is effectively early low TRL stuff where you need work to be done that is sort of sustained and has a long-term agenda and thinking around it. And then you have engineering teams which work on things where you actually pivot quickly. And so that's how you find the balance between incorporating all of the stakeholders of university into what you do.
Yeah, thank you. Staying with the topic of the university and how to work within the resources of the university and potentially the challenges of a university, Gaurav, you mentioned in your presentation the value of making some of your projects or the Institute more generally a campus-wide initiative, and also having support of some key players at the university, such as the Vice Chancellor for research and creative activities. Based on your broader experience, what can universities do from a structural or support perspective to make it easier to develop and sustain relationships between university researchers and cross-sectoral research partners?
That's an excellent question. The short answer is I don't really know. I'm not sure that there's a model for this. I think we've been very fortunate to have some really progressive leadership that's also been willing to take chances. And I think that being the case, a good question perhaps to be asking is, what are the different ways by which, as a university, we're willing to make our impact felt in the world? And I think if we choose to ask that question and sort of push and probe at it maybe a little bit more aggressively than we usually would, I think that's really where the solutions emerge. But I don't have substantial words of wisdom to really try and address that question more formally.
Gaurav, both you and Tom emphasized the idea that ICM in some ways operates like a startup company rather than a traditional university lab. And I wonder whether there are certain things that universities can do structurally to make it easier for research units like yours to operate somewhat like a startup.
I think it requires two things, right? I think that the biggest thing that these efforts need is I think they need focus and they need resources. I think if you can align around a focus, I think that's the first place to start, because once you have a focus, then you can go figure out how to really align and allocate resources to be able to fulfill focus areas. So I think that's really the right place to start.
Tom, did you have anything to add to this?
No, I mean, and I think when you think about the projects we work on, they're projects that people care about, they're impactful, and really they align with a lot of the goals of major institutions to decarbonize. So we're relatively, I guess, lucky that we're working on a project that is universally cared about in the university setting. And I think that sort of does help bridge a lot of the gaps. I know that doesn't really answer how do you structure it like a startup, but I think it really is important to have that universal buy-in, because when you're hiring engineers in a university that aren't typically employed, you do have to explain to people what you're doing and why you're doing it, and have an alignment of really the goals of all the projects you're working on, because without that you get a lot of questions. Yeah.
Well, perhaps to some extent, this depends not only on the structure of the university, but on where the funding sources are that you're turning to support this work. So the area of research that the ICM is involved in is increasingly attracting funding sources outside of government and agency funders that are more typical supporters of research at universities. Does the non-traditional nature of this funding change your approach to the design and implementation of these projects in any way?
I'm not sure it changes our approach to design and general thinking around the projects. I think it does affect our speed of decision making, and I think speed of decision making is perhaps something that's really important. And it also sort of does offer flexibility with how we can pivot projects. And I think that's an important part of it. So I think very often when you have structured government funding, it follows a program, follows a timeline, follows an agenda, and you don't have the ability to pivot a whole lot from it. I think with other kinds of funding, you often have that flexibility, and that is important to have.
Yeah, thank you. I wonder if we can circle back to the question about graduate students, and the issue of whether universities have the opportunity to enable greater numbers of graduate students to participate in deep partnerships with problem solvers outside of academia, focusing on impactful projects like the ones that you're doing that are intended simultaneously to discover new knowledge and address societal problems. So are there things universities can do to retain graduate students who are motivated to do work that will benefit society? Do you have any thoughts about this idea?
Yes and no, right? So there is things that we can do, but there's also reasons for which we may not always want to stray too far from an established model. I think a big part of doing a PhD really does involve becoming a subject matter effort in a very deep way in a given area. This may not always be well suited with engagement on the outside because it often does not have a really well-defined commercial character to it. But you need to still develop that deep knowledge base and that deep expertise. And once you have that expertise, then you need to try and figure out how to pivot and apply it on the outside. So maybe one way of doing it is to really go out and get that expertise, and maybe towards the end of a student's PhD, that's where you really start to engage them with other entities on the outside, because that's also the point at which they've got a deep subject matter basis of knowledge, and they know how to best apply it as well, make it useful to somebody else.
Yeah, thank you. So you've noted that decisions need to be made quickly. What is driving the speed of decision-making in your work? For example, is it funders' expectations? Is it any expectations of the academic institution? Is it pressing societal challenge, industrial timelines? What is it that really drives the sense of the time frame of your work?
It's really the ambition of the projects and the ambition of the people that drive the projects. I think what you really reward with decision making is you reward people by making them aware and having them appreciate that the work that they do is important, and hence you're willing to make quick decisions about it. I think that's fundamentally important, right? And that's how you reward people in a way as well. And so decision making is not simply just decision making for the sake of decision making, but it's really for meeting project ambitions and for rewarding people's sense of purpose in the work that they do.
Can you talk a little bit about the decision-making process that you follow for your specific project?
Right. Again, there's not a single model, so to speak, but really, you can make decisions quickly when you're not operating in an information vacuum. And what this really involves is being surrounded by incredibly good people that have experience and that know what they're doing. And what that means is you can lay facts on the table really quickly, get a priority around which of those facts actually matter more and which ones matter less. And then with the limited amount of information that you have, I think doing what lots of good engineers do, using judgment. And I think judgment in some ways is sort of the hardest part because it sort of develops as a function of time. And you learn how to make these decisions better versus worse. And that's how you follow a decision-making process. And so you've got to be able to go through that, both the laying all the information out on the table process quickly. You need to go through sort of ruling out the high priority versus the low priority areas and keeping only the high priority areas and questions behind, and then being able to make good decisions with limited information on hand.
I mean, I also want to point out that the timeline of the projects that we mentioned, when you talk about being impactful 10 years, and you talk about building something that's going to be removing carbon on the gigaton scale, you start to go back, work backwards and say where you have to be able to be successful and to be able to physically build something that large and the infrastructure required. And you really realize that if something is going to delay you a year or 2 years, a decision becomes really easy if it's a matter of taking a time delay or a new avenue of research or application. Yeah.
Often decision-making for HIBAR projects is complicated by the fact that you have multiple partners working together. And I wonder whether you have figured out a more streamlined approach within ICM, or whether you have the usual challenges or complications of academic researchers working within university systems, and then also complicated by the fact that you're working with partners out in society.
I mean, I think it goes back to goal alignment. I mean, with all the projects, I think we do have really good buy-in on what the end product is, whether it's carbon capture, cementitious materials, or minerals like lithium. most people care about the end result. We do have a technology path that we're following that's based on, our patented processes and staying within what we have protected that way.
Perhaps, Tom, let me just jump in and ask if communication is an important part of the decision-making process, and whether you've experienced any communication challenges with people with different backgrounds and experience, and whether you can offer any advice to others who are working on similarly complex projects that require input from people in multiple fields.
I mean, we do spend a lot of time communicating with the various organizations we're affiliated with. That's of course important. I mean, every funding source has required reporting, and that's certainly important. Communication internally, I mean, there are things that we do that might be a little different. We do emphasize in-person, research and work. We meet in person. Gaurav and I are in the same room. We've been, meeting with people all morning. I don't see communication as a big hurdle, but it is something that's important when you're communicating across teams and across projects. It hasn't really been too big of a challenge, and I don't know if that's. I mean, it could be partly the pandemic that's made virtual communication with third parties more common and more accepted. But it's been pretty seamless. I mean, we deal with. I mean, I've hired a team in Singapore. We're working at opposite ends of the clock, but we still find time to meet relatively regularly with vendors there, and it's become a lot more normal, I think, to do that.
Mm-hmm. Mm-hmm. Yeah, one of the unique aspects of ICM is how, in a sense, the cross-sectoral idea has been turned inside out, in that partners who might traditionally exist outside of the academic environment are actually brought into ICM, invited to become members of ICM in a sense. And so I wonder if you could talk a little bit about the model at ICM of bringing people in from external industrial affiliations and making them actually part of the academic unit.
Yeah, I think a big part of this is really based on the recognition that this is not something that we're going to do on our own. And I think it's really about understanding, doing and this is a part of the landscape analysis. It's really trying to understand, if you want to make a difference in a range of areas, what's the key stakeholders you need to bring in, and what are really the mission priorities that you need to align against, so that all of the stakeholders get something of value at the end. I think you have to really understand this aspect on the value that you offer and the value that you deliver. And if the value proposition is clear enough both ways, it's very easy to get non-traditional partners involved. And I think that's really sort of the secret sauce, so to speak.
Mm-hmm. But also, it's my sense, and correct me if I'm wrong, that ICM has developed a model where that changes the notion of cross-sectoral collaboration, where some of the partners who might traditionally have existed outside of the academy are made formal partners within the institute.
I think I would agree with that. I think that is true. That that we have developed a way to be able to bring in people that historically would not easily be a part of the university enterprise, so to speak.
Does this seem to be a model that can be replicated in other fields, or is there something unique about the field of carbon management that you're in?
No, I don't think there's anything unique about the field of carbon management. I think we've got a unique approach by how we've actually tackled it, and I think the approach itself is definitely replicable.
Yeah, thanks. I wonder if we could ask some questions just related to your personal experience, yours and Tom's as well, personal experience with ICM. And you said that ICM has existed for about 4 years now. So that's enough time to see what's working well and what you might tweak if you were to do it over again. I wonder if you were to start an organization like ICM all over, would you do anything differently, or are you particularly pleased about some of the decisions you've made in creating ICM along the current model?
I can't really say there's anything that we would have done differently. We would have definitely hoped there weren't a pandemic in the way. but I think there wasn't really much of a choice about that one. I think we've learned a lot, and I think we've learned a lot about what we could have done better, but I don't think there's anything we would have done differently.
Is there anything in particular that the pandemic affected in your creation of ICM? Or how did you do your work differently?
No, I don't think it affected the creation at all, but I think it did affect operationally how we do work. One of the things that I really came to realize over the course of the pandemic is that in-person interactions are incredibly important to the work that we do. The kinds of work that we do is just extremely poorly made to be done in 2 dimensions. And the idea of being able to get up with a group of people on a whiteboard and sketch things out and push and probe on ideas is something which has to happen with significant attention and with presence. I think that's really one of the biggest things that we learned. We also, there's a big part of what we do that also involves human trust and human interaction, which is much easier to build face-to-face. It involves exercising judgment, again, which is much easier to build trust around face-to-face. And I think, don't get me wrong, while the idea of being able to interact virtually is incredible, I think it definitely helped us understand the value of face-to-face interaction, which I think is enormous and basically irreplaceable.
So it seems that some of the work that you're doing could hypothetically be happening at a non-academic startup company, and yet you've chosen to do this work within the environment of a university. Did you and have others in your organization ever faced a decision about whether to stay at the university or work full-time for a for-profit company? And what is it that convinced you to do this work within the academic environment?
Yeah, so I've been really fortunate to be surrounded by a group of people that's really focused on impact and on outcomes. And that being the case, I think many of us go through our careers examining and evaluating the choices before us. And many of us have evaluated whether academia is the right fit or not. I think eventually we've all come to understand that academia offers this wonderful flexibility of intellect, this wonderful flexibility of the kinds of work that you can do, and offers I would say, a custom-made pathway to deliver impact if that's what you really want. Nothing's ever perfect, but perfection is also the enemy of the good. And we think that this is a great model for us to be doing the things that we want, where it allows us to work on technology, allows us to mature technology, and then allows us to transition it into companies where you bring in professional talent to run those companies. But you can also get amongst the best management teams because you've really put in the time, you've really put in the effort to do things to a point of preparation that really credible people are engaged and want to come on board.
Yeah, and an example of that, I think, would be Tom, who moved from industry back into academia. And maybe
That's exactly right.
Tom, you could talk about that a bit.
Sure. No, and I mean, I think one thing, having been in industry for so long, that you see is the decisions are very much financially motivated in industry, and almost to, I shouldn't say almost to a fault, but often to a fault. You can, if there's a hurdle that involves spending money outside of a budget, oftentimes projects are killed. And the benefit of the university is you have this non-traditional funding structure that doesn't exist in industry. I mean, I remember working on, early on in my career, we had a couple of projects funded by the Department of Energy, and those were some of the most challenging ones for industry, because you had goals that were separate from delivering a product, where here we can go after those funding sources and use them to de-risk our processes, so that when there's a certain point where you find people like myself say, this technology is interesting, you've got it far enough where I think I can build a plant and a process. And I mean, there'll be a point for myself where I may go with one of the startups if it's one that, I'm personally vested in or something like that. But I can also stay here and continue to work in the environment that I'm in. And we have a pipeline of various technologies that are at a similar state. But I think you almost have to get to a certain point from an academic stance to say that, okay, you're ready to scale. And then it becomes interesting, but for someone to join ICM, but the technology isn't necessarily ready for standalone to be a company. So there is that sort of internal bridge that you have to finish to be able to de-risk that and make it able to stand on its own.
Mhm. Well, thank you both so much for instructing us about how things work at ICM. It's really been a very informative webinar, and also for telling a bit about your personal stories. We have a couple minutes left, and I'd like to give you a chance to offer a few final takeaway messages for our attendees.
Nothing further from me, Scott.
Okay.
Nothing further from me. Thanks for the opportunity.
Thanks, Gaurav. Tom, did you have a few?
Sure. No, I mean, I think you can see how ICM does sort of embrace the HIBAR principles, even though it may be not necessarily intentional, but to be able to do that highly basic initial research in a university and have these projects led from the university to have the industrial impact, I think that's really what ICM is all about. So it was really interesting for me to learn about HIBAR and say, no, this is what we're doing, and more people should do it.
Yeah. Well, the work that you're doing at ICM is not only fascinating, but extremely important to, the issues that we face in the world. So we appreciate what you're doing, and we appreciate the time you've taken to do this webinar with us for the HIBAR community. So thank you, Gaurav and Tom, and thanks to everyone who's attended today's webinar. And please stay tuned for announcements for future events in this series. Thank you.